So my name is Dr. Nadia Saba. I am a mechanical engineer and I specialize in designing climate control systems for agricultural and commercial buildings. I also have my PhD in agricultural engineering, and I studied at the University of Arizona in the Controlled Environment Agriculture Center, where I studied greenhouse cooling design. And I specialize in evaporative cooling, so pad and fan, fog and mist systems, as well as natural ventilation. So how much should you open up your sidewalls and your roof to allow naturally ventilating climate control in a greenhouse? I advise growers on how they can improve their climate control system. So for instance, one of my clients in Denver, they have an existing, very large, about 100,000 square foot indoor grow. And they invited me out there to troubleshoot some of the problems that they were having and also talk about how they might do it better the second time. And so I just walk around the facility and, I point at things and say, you can do this a little bit better. Oh, you should consider, redesigning this area. But really all focused on heating, cooling, ventilation, and dehumidification or humidity control. So I can do that for your flower, your veg rooms, as well as cure and clone. And if you can tell me what your loads are, so how much water are you irrigating your plants, what types of lighting are you providing and how much lighting, I can actually calculate exactly how much cooling you need and how much dehumidification you might need during day and night cycles. So I can either consult you on an existing facility, but I can also help you design a brand new facility. And so one thing that, I'm an engineer, and one thing that I specialize in is designing engineered systems. So, a lot of startups, they're trying to get into a building and start growing as quickly as possible. And so, they'll choose just a package carrier train unit that's really simple that they can plug in and start growing. And I get that. It's a really cheap solution. It gets you, at least a climate that you need to get started. But then what happens is a lot of times is that growers will come back to me a couple of years later. They have experience growing. They know that they can do better. And they say, Nadia, can you please help us engineer our next HVAC system? So, we know that we can do better with humidity control. We know exactly what temperature and relative humidity set points we want because we have this experience. And our existing, package off-the-shelf system just can't get us to where we want to go. Can you help us do that? And one of the biggest challenges with indoor grows is nighttime dehumidification. So I can help you select a system that can actually dehumidify at night without overcooling the climate inside. So that's really where I specialize and where I can add value to your next project. Let's start with a 5,000 square foot grow room, okay? So it can either be veg or it can be bloom. We'll put cure and clone off to the side for right now. So what would be ideal is a system that can actually vary based on temperature and humidity. So you have a thermostat, but you also have a humidistat in the room that's monitoring both temperature and humidity. And then what happens is that the sensor actually sends a signal to the HVAC system and says, I need cooler temperatures, or I need more humidification because my relative humidity is rising, or my temperature is going above where I'm comfortable. And that system, there are systems out there that can actually vary the compressor speed, vary the fan speed, and really fine tune exactly how much cooling you need to achieve both dehumidification and cooling. So in terms of what the ideal temperature and humidity set points, really that information should come from you. I can give you recommendations of what I think based on my experience, based on the most up-to-date research and anecdotal evidence from some of my other growers, without divulging too much information about what they're doing. But really that information needs to come from you. So if you tell me you want a temperature set point of 78 degrees and a relative humidity of 45%, then I'm going to size and select an HVAC system that can achieve those set points. It's not going to overshoot the temperature. It's not going to undershoot the relative humidity. It's going to give you exactly what you need and when you need it. And the nighttime conditions can be especially challenging because we don't have a cooling load. Your lights are off, so all that heat is not in the room, but your plants are still breathing, right? They're still producing some moisture, maybe at 30% of what they would produce underneath the lights. And so how do we manage that humidity? How do we keep the humidity low at night? And there are some strategies that I can help you figure out what system is best for that. Is it a standalone dehumidification system in the room? Or are we using that same HVAC system to actually provide the dehumidification without the cooling? And there's some tricks to that, and I can help you do that. You don't have to have 4 or 5 different systems in the grow room to achieve the different conditions. In a lot of cases, we can do it with the same exact system. But not everybody understands that, and if you come to me, I can help you figure that out.